The importance of sleep as a recovery strategy is well known and recognized by coaches and athletes. Considering previous findings, sleep duration and sleep quality play a determinant role in the optimization of sports performance, recovery process, and maintenance of the quality of life and health in athletes. Thus, ensuring proper patterns of sleep can positively impact performance, while sleep disturbance can ultimately be harmful not only for performance but also for the health of players. For example, heavy training demands can also disturb sleep quality, especially in young players. Additionally, players are often exposed to travel that may negatively impact sleep routines. Naturally, other factors related to sleep hygiene, such as exposure to light, or the ingestion of caffeine or alcohol, can also play an important role in how and how much players sleep. Despite the above-mentioned studies, there is still a need for more research to help understand the direction of relationships between sleep quality and duration and training intensity to which players are exposed. In particular, understanding how the training intensity of one day may impact sleep after training or, on the other hand, how sleep may impact the training intensity of the following day is critical to helping the academic community enrich the evidence regarding this topic. Materials and methods. We followed an observational study design. The players were monitored for their daily sleep quality and duration and training intensity over a period of 2 weeks. This period started 20 weeks after the beginning of the season. 4 training sessions occurred each week and 1 official match occurred over the weekend. The training sessions started at 6 p.m. The match days occurred at 7 p.m. on Sundays. The training sessions occurred on Tuesdays, Wednesdays, Thursdays, and Fridays. On each day, the consensus sleep diary was answered by players. In addition to sleep measurements extracted from the diary, all field-based training and match intensities were quantified using the CR10 gauge scale, and heart rate monitor and a Polar Team Pro GPS unit. A repeated measures test was conducted to analyze the weekly variation of sleep quality and training intensity measures. A correlational analysis was conducted to analyze the relationships between sleep quality and training intensity. The sleep quality was correlated with the training demands of the same day and the opposite. An overview of typical schedule activities is presented in the table. Participants. 20 youth male soccer players voluntarily participated in the current study. Players were from the same team, selected by convenience sampling. The team participated in the Elite Academy League. Players were enrolled in 5 training sessions a week plus an additional match. The eligibility criteria for including participants were the following. Measuring sleep duration and quality. The consensus sleep diary was used as the instrument to measure sleep duration and quality. During the 2-week observation period, each participant was asked to fill out the consensus sleep diary during the first 2 hours after waking up. The items of the questionnaires were the following. With ultimate measures extracted, we collected the items: sleep duration, time to fall asleep, quality of sleep, and rested feeling. Heart rate and locomotor demands were objectively measured using heart rate monitors and GPS. In each session, the following measures were collected. Total distance, pace, average distance covered per minute, maximal speed, peak speed registered in the session, distance covered at zone 1, distance covered at zone 2, distance covered at zone 3, distance covered at zone 4 and distance covered at zone 5. For the internal intensity, maximum heart rates of all athletes were determined during the 30 to 15 intermittent fitness test in the previous weeks. Maximum heart rates established in previous weeks were used for this study. Results. Descriptive statistics of intra-week variations of sleep and training demand outcomes can be found in the table. Repeated measures ANOVA revealed significant within-week variations in sleep duration, quality of sleep, RPE, session RPE, HRmin, HRpeak, total distance, pace, distance covered at Z1, Z2, Z3, and Z4. However, no significant intra-week differences in the time to fall asleep, rested feeling, session duration, HR average nor peak speed were found. Pairwise comparisons revealed that, on MD2, the sleep duration was significantly longer than on MD4 and MD5. MD2 was significantly more intense regarding RPE than MD, while MD4 was more intense in RPE than MD5. The MD5 had significantly lower session RPE than MD2, MD3, and MD4. The MD4 had significantly greater minimum HR than MD and MD3. The HR peak was significantly higher in MD3 than in MD. Significantly less total distance was covered on MD4 in comparison to MD, MD2, and MD3. Moreover, significantly less total distance was covered on MD5 in comparison to MD and MD3. The pace, meters covered per minute, was significantly higher in MD3 than in MD and MD4. Distance covered at Z1 was significantly lower in MD4 than in MD, MD2 and MD3. Similarly, distance covered at Z1 was significantly lower in MD5 than in MD, MD2 and MD3. The distance covered at Z2 was significantly lower in MD4 than in MD, MD2 and MD3. Moreover, the distance covered at Z2 was significantly greater in MD3 than in MD2 and MD5. Distance covered at Z3 was significantly greater in MD than in MD2, MD3, and MD4 and MD5. Regarding the distance at Z4, significantly more meters were covered in MD than in MD2, MD3, MD4, and MD5. Additionally, significantly less distance covered at Z4 was found in MD5 in comparison to MD3 and MD4. The distance covered at Z5 was significantly greater in MD than in MD2, MD4, and MD5. Finally, in MD3, significantly greater distance covered at Z5 was found in comparison to MD4 and MD5. Table presents the correlation coefficients of sleep and training after sleep. This means that only MD, MD2, MD3, MD4 and MD5 were correlated, since no training occurred at MD1 nor MD6. Significant small positive correlations were found between sleep duration before training and session RPE, total distance, distance covered at and distance covered at Z2. The table presents the correlation coefficients of training demands with the sleep outcomes after matches. Significant small correlations were found between session RPE and sleep duration after matches, total distance and quality of sleep after training, distance at Z1 and quality of sleep after training, distance covered at Z5 and quality of sleep after training, session duration and rested feeling after training, total distance and rested feeling after training, distance covered at Z3 and rested feeling after training and distance covered at Z5 and rested feeling after training.